Alright, let's go. Number 10. Chemical rockets. The method that already burned out. Chemical rockets are the foundational fire of human spaceflight. They shattered our atmospheric chains. They carried us to the dusty surface of the moon. They flung mechanical probes into the freezing, lightless void beyond Pluto. But here is the brutal truth that space agencies rarely advertise. Chemical propulsion has already hit a permanent, insurmountable ceiling. The problem is dictated by the unforgiving tyranny of the rocket equation. To go faster, you need more fuel. More fuel adds mass. More mass demands even more fuel. It is a vicious, inescapable cycle of diminishing returns. There is no engineering fix. No clever modification. Physics simply will not permit it. Because of this, even the fastest chemical spacecraft ever engineered by human hands would take upwards of 70,000 years to reach Proxima Centauri, our single closest stellar neighbor. That is not exploration. That is waiting longer than every recorded human civilization has ever existed. You are boarding a vessel with the absolute certainty that you, your children, their children, and 10,000 generations after them will never arrive. Chemical rockets did not fail us because the fire is weak. They failed because the cosmic ocean is impossibly, terrifyingly vast. Number 9. Nuclear pulse propulsion. Riding-controlled destruction. If chemical fire is too feeble, perhaps the answer is the most destructive weapon humanity has ever built. This concept sounds less like engineering and more like the frantic blueprint of a madman, yet it was seriously funded and studied by the brightest physicists of the Cold War. Project Orion. The ship drops a nuclear warhead out the back. It detonates. The resulting shockwave slams into a massive, shock-absorbing pusher plate bolted to the stern of the vessel. Each atomic explosion adds compounding momentum. Each blast shoves the ship faster and faster into the dark. Theoretically, this brutal, unrefined approach could push a massive arc to 10% the speed of light, meaning a journey to Proxima Centauri of roughly 40 years. But stop and fully process what that journey entails. You are not riding a humming, elegant engine. You are riding a relentless chain of thermonuclear detonations. You are subjected to continuous shockwaves. You are bathing in the radiation of your own exhaust. Interstellar travel ceases to be a glide through the cosmos. It becomes an act of sustained, controlled destruction, physically detonating your way across 4 light-years of absolute nothing. Number 8. Nuclear fusion. Building a star just to escape one. If primitive nuclear bombs aren't enough, humanity must turn to something even more primal. Fusion, the exact same thermonuclear engine that powers the Sunday. By forcing light atomic nuclei together under immense heat and pressure, we could theoretically accelerate a spacecraft to a significant fraction of the speed of light. Suddenly, the nearest stars are not tens of thousands of years away, they are decades away. And here is where it gets genuinely exciting and then immediately terrifying. In December 2022, the National Ignition Facility in California made history. For the very first time in a laboratory, a fusion reaction produced more energy than the laser energy delivered to trigger it. They did it again in 2023, and again in 2024. By April 2025, a single NIF shot yielded 8.6 megajoules from just 2.08 megajoules of input, a gain of over 4 times. Fusion ignition is now real, repeatable, and improving. But we are still decades away from a stable power plant, let alone a Starship engine. You are now tasked with caging a miniature star inside a metal reactor, plunging it into the freezing vacuum of deep space, and maintaining that delicate, violent reaction continuously for 30 years. A single, microscopic fluctuation in the magnetic containment field means plasma expands. It touches the reactor wall. The ship, and everyone aboard, is instantly vaporized. We lit the fire in a laboratory. Keeping it burning in a spacecraft hurtling through the void is an entirely different nightmare. Number 7. Antimatter engines. The fuel that destroys everything it touches. There is nothing in the known universe more powerful or more violently efficient than antimatter. When matter and antimatter collide, they annihilate each other completely, converting 100% of their combined mass into pure gamma-ray energy. No exhaust, no wasted fuel. It is the absolute pinnacle of physics. A perfectly engineered antimatter drive could push a spacecraft to 50 or 80% the speed of light. You could reach another star system well within a single human lifetime. But the catch is apocalyptic. Antimatter does not just produce energy, it destroys anything it physically touches. Humanity can currently synthesize only microscopic fractions of a gram, at a cost of billions of dollars per milligram. And storing it requires suspending it in complex electromagnetic fields to prevent it from contacting any surface. Because if it touches the wall of its container, that wall ceases to exist. You must somehow carry metric tons of this annihilating substance on a vibrating, accelerating spacecraft crossing 4 years of interstellar void. A single mechanical failure, a momentary power fluctuation, one microscopic containment breach, and the entire ship flashes into a brilliant sphere of hard radiation in a fraction of a second. It is the perfect interstellar fuel, and the most terrifyingly dangerous substance we have ever seriously considered harnessing. Number 6. Solar and laser sails. Riding light into the unknown. What if the solution to the mass problem is to simply stop carrying fuel altogether? What if light itself does the pushing? Solar sails use the momentum of photons, weightless particles of light, to generate a continuous, silent thrust. In the frictionless vacuum of space, that tiny pressure builds relentlessly over months and years. Now, weaponize that concept. In 2016, billionaire Yuri Milner and the late Stephen Hawking pledged $100 million to the Breakthrough Starshot initiative, a plan to aim gargantuan, Earth-based laser arrays at microscopic wafer-thin sails, blasting them with 100 gigawatts of focused light. Under that intense artificial beam, a gram-scale probe could be violently accelerated to 20% the speed of light within 10 minutes. As of 2024, the project's researchers have identified silicon nitride as the leading candidate material for the sail. But the laser infrastructure alone must drop from $100 per watt to between 1 and 5 cents per watt, make the mission economically viable. The program has quietly stalled on these engineering realities. Scientific American, and even if every single obstacle is solved, there is one final, catastrophic problem that the enthusiasts gloss over. Once you accelerate to 20% the speed of light using an Earth-based laser, you have no onboard fuel to slow down. You cross the dark for 20 years, only to fly straight past your destination at unimaginable speed. You cannot stop. You cannot even wave goodbye. The universe just watches you streak past in silence. Number 5. The Bussard ramjet. When the universe offers a solution and then takes it back. The void between the stars appears completely, utterly empty. But it is not. The interstellar medium is laced with rogue hydrogen atoms, spread incredibly thin, invisible to the naked eye. The Bussard ramjet proposes a radical solution. Instead of carrying fuel, build a ship that collects it as it flies. Deploy a massive electromagnetic funnel, a scoop potentially thousands of kilometers wide, gathering those stray hydrogen atoms and funneling them directly into an onboard fusion reactor. As the ship moves, it feeds itself. It becomes a theoretically self-sustaining vessel that can accelerate forever without ever running dry. The theory is beautiful. The physics is mathematically crushing. The hydrogen in the interstellar void is simply too sparse. The electromagnetic scoop required to gather enough fuel must be so unfathomably large that it acts like a parachute. The physical drag it creates sweeping through the interstellar medium cancels out the thrust generated by the engine. And worse, the proton-proton fusion such a reactor would require is so thermodynamically inefficient that the reactor would likely consume more energy than it produces. The universe dangled a perfect solution directly in front of us and then quietly made it mathematically illegal. Number 4. Generation ships. A journey you will never finish. If physics refuses to let us travel fast enough, humanity must fundamentally alter its definition of what a journey actually is. Generation ships do not attempt to beat the crushing distances of space. They simply surrender to them. These would not be ships. They would be flying worlds massive, enclosed ecosystems carrying tens of thousands of humans, designed to sustain life, agriculture, and civilization for centuries. The people who walk aboard and wave goodbye to Earth are not the ones who arrive. You are born inside a spinning metal cylinder in the dark. The sky is steel. The horizon curves upward above you. You will live your entire, finite life inside this artificial shell, working, breathing, raising children, and eventually dying purely to ensure the ship's systems keep functioning. You know a destination exists. You know your distant descendants will one day walk on alien soil. But you are fully aware that you are not a traveler. You are biological infrastructure. Your entire existence is to be a living, breathing component in a legacy you will never touch. Number 3. Cryogenic sleep. Turning humans into cargo. If the psychological horror of generational imprisonment is too much to accept, we attempt to cheat time itself. We pause biology entirely. Cryogenic suspended animation proposes plunging astronauts into a deep, icy stasis, halting their cellular aging completely. The crew sleeps. Centuries pass in the silence of the void. They wake up unchanged in the orbit of an alien sun. But science fiction dramatically oversimplifies the fragility of the human body. When human tissue freezes, water inside cells forms jagged ice crystals that mechanically shred cellular walls from the inside. We currently have no medical technology capable of safely freezing complex human organs and reliably reviving them. Furthermore, the human brain is not a hard drive. You cannot cut power, let it sit frozen in an irradiated vacuum for 3 centuries, and expect it to seamlessly reboot. You close your eyes inside your pod, surrounded by the distant hum of automated systems, fully aware that your biology might simply refuse to restart. You are surrendering your consciousness to machines that must not fail not once for hundreds of years. It is not sleep. It is gambling your existence on clockwork that has never been tested at this scale. Number 2. Warp drive. Breaking the universe without breaking the rules. Einstein declared that nothing with mass can travel through space faster than light, but his mathematics contained a razor-thin loophole. He put a speed limit on objects traveling through space. He never put a speed limit on space itself. This is the Alcubierre warp drive. Instead of pushing a ship through the void, you manipulate the fabric of reality. The drive compresses space-time ahead of the vessel and expands it behind. The ship remains perfectly stationary inside a protected bubble, while space flows around it at superluminal speeds. No acceleration, no time dilation, no violations of relativity. The math is legitimate. NASA physicist Harold White later revised Alcubierre's original energy requirements, reducing the exotic matter needed from a Jupiter mass quantity down to roughly 2 metric tons, and as recently as 2026, new theoretical frameworks continue to refine the geometry of these so-called warp nacelles. But the fundamental wall remains. The drive demands exotic matter material, possessing negative mass, a substance that has never been observed, created, or proven to exist anywhere in the universe. You are not navigating space. You are demanding that reality itself bend to your will, and reality has absolutely no obligation to comply. Number 1. Wormholes. The door that snaps shut the moment you try to walk through. If the scale of the universe is too vast to ever cross, the final, desperate solution is to stop trying to cross it entirely. We step through it instead. Wormholes, Einstein-Rosen bridges, are theoretical tunnels that fold the fabric of space-time, connecting 2 points in the universe that could be millions of light-years apart. No acceleration. No centuries in the dark. You step into the throat of the anomaly, and you step out into the light of an alien star system. General relativity permits their existence, but quantum mechanics ruins the dream. A naturally occurring wormhole is violently unstable. The immense gravitational forces cause the tunnel to collapse in on itself in a fraction of a millisecond, far too fast for anything to pass through. To keep the throat open for a spacecraft, you would need to shore up the collapsing walls with exotic matter possessing negative energy density, the same phantom substance that haunts the warp drive. And even if you somehow obtained it, the quantum vacuum fluctuations inside the tunnel would rapidly amplify into radiation intense enough to destroy both the wormhole and anything inside it. You are staring at a perfect doorway to the entire universe, fully aware that the instant you attempt to cross the threshold, the tunnel snaps shut and erases you from existence. We have engineered rockets riding controlled nuclear fire. We have drafted blueprints for metal worlds designed to outlive empires. We have mapped mathematical loopholes through the very fabric of reality. And yet humanity remains exactly where it started, chained to our solar system, staring into the dark instead of sailing into it. Reaching another star is not merely an engineering problem. It is the ultimate test of whether intelligence can survive long enough to escape the cage it was born in. And the most chilling truth of all? We have only just begun to understand how hard the cage is.